We are back from the break. If we can break up the discussions and do a little bit more appling. We're going to have plenty of time to talk later during our reception too. So there will be opportunities also to talk with me in between these talks. So we're going to do a little pretty brief part about vehicle data, just to give you an overview and an idea of what we do in vehicle data. And then we move on to the SDL part of this developer day and developer conference day. Vehicle data. We're going to talk about available data, how to get the data, and how to simulate the data. And we actually covered most of these topics already, so we're going to step through this relatively quickly. This is all you can get. These are all the vehicle data items that are currently defined in Smart Device Link. We have one pretty big disclaimer on vehicle data regarding real cars. Now, I'm not sure how many of you worked for a real OEM and tried to develop a car. It's actually quite complicated. And so one part that comes with that is that different cars are quite different from their electrical architecture and what signals we can actually get out of these cars. So the disclaimer I have is that not all cars support all vehicle data items. We have a couple of vehicle data items that are there on most of the cars. So for example, if you go to GPS and speed and stuff like that, we have that on pretty much all of our cars. But you go maybe further down the list and you get to like the acceleration pedal or the steering wheel angle, you will not get that on all the cars that we have. So we were talking about best practices earlier. When you create an app that is dependent on vehicle data items, please always make sure that you have the possibility in mind that this car you're connected to does actually not support this vehicle data item. So you have to inform the customer or the user that your app may not work with their car or may only work with a degraded functionality and does not have, for example, a feature where it shows the pedal position or something like that. Now, when we go through this list, you see the types of data you get back, and you see a couple of float, integer, you see a couple of structs. So these structures are basically data structures that we created to represent all the items that are behind the vehicle data part. So for example, for GPS, you don't only get the GPS location in lat long, but you also get the heading and PDOP, VDOP values and other stuff that may be useful for you. So the structure, when you go into documentation, you can have a look at the struct and you can see, get all the different items that are in there, and it's pretty straightforward to get in there and see what it contains. This chart only tells you struct, but for example, the headlamp status, this is the force from the bottom, gives you low beam, high beam, and stuff like that. So it's not just an easy float or integer value. It's actually more readable for you as an app developer instead of just giving you headlamp status 1, 2, 3, 4, 5, and you have to figure out what it is. We actually give you the information in a more readable format. And again, we were talking about belt status earlier, so I cannot promise you in how many cars you will get that, but it's in here in our list, so you can have a look at that and try out these different vehicle data items. All these items are actually grouped, so in something we call a functional group. So we put together vehicle data items that have similar content, for example, GPS and speed. And when you request access to these items from us for a real car or for a technical development kit, you will always get access to a group of items. So you don't say, I want to have GPS, I want to have VIN, I want to have tire pressure, but you can also say, hey, I want to have the functional group of location and stuff like that. We don't have that broken down here, so just come talk to us and we're going to tell you what functional group it is you need. Any questions on these vehicle data items? Yes. The question is, can you get the reverse? So in the Prindle enum, you can get the reverse. Excuse the hardware limitation?
I was hoping to see like 38 PSI instead of just
So the question is, can you get the absolute value of tire pressure instead of these more informational items like normal and low? The answer to that is currently we only have the items that are on this list, so we don't have an absolute value for the tire pressure at the moment. Now, one little note on that, Smart Device Link is an open source project, so if we see a lot of developers that are really interested in specific items, we will consider it to be added in the future. So whenever you're interested in, even though we may not be able to do it right now, but maybe we can add that in the future and enable your app to work in the future with cars. So let us know what you're interested in. If it's not on this list, we're going to take a note, and we're going to definitely look at that for future revisions of Smart Device Link and future versions. So the question is, how do we know what vehicle data items are available on what percentage of cars on the road or something like that, and if it's a good idea to hop into each car and test it. So if you hop into each car and test it, and also each trim level and each region, then let me know and just send me that table, because I would love to know that. It's a pretty complex situation where you don't really, there are a lot of cars on the road that support Smart Device Link and AppLink, so it's really hard to get percentages on this. We do have a general feel, as I said earlier, about what vehicle data items are available on how many cars. We can get you more insight if we need that, but we don't have publicly available data. It just changes too often. Other questions? Yep.
About stick shift. What about stick shift? What happens to the spindle with stick shift?
I am not 100% sure. The question was about stick shift. Do we get information about stick shift? I have to go back and check if that is given back in the prindle. I look at my devs in the back. Does anybody know if the manual? Yes? Okay, so the prindle enum will give you back the gear that you're in when you're in a stick shift. Yep, please.
I have a question on braking. If you have just the Boolean to do, is there a way to give an actual deceleration rate?
So the question was, is there a way to get deceleration in probably G's, is what you're looking for, something like that? And the answer to that is, we have what is on this list at the moment. So no, there are no G values on there. So we don't have that in our vehicle data items. We may look at that in the future, so we're going to write that down and see what we can do. But for the braking part, we don't have that at the moment in there. All right, so these are the items. If you got any other questions, you can come back to us and we can talk about the different vehicle data items and availability and stuff like that. Again, this is also a reference that you can use while you're developing. And then there's the big red mark, always important. So we talked about how to get vehicle data one time versus subscribing. So we can probably step through this relatively quickly. So you got the one-time checks for get vehicle data. There's the Android response and also the iOS one just below that. So this is how you get your responses. Generally, we were talking about responses a lot. All these responses come back as notifications, as callbacks into your apps. So you basically have to write out a function, which is in this case called on vehicle data. And this function is being called when there's a response incoming. Notification-based, subscribe vehicle data, and you're all experts by now, so you know use subscribe vehicle data to get the vehicle data on a more ongoing basis. And then we were talking about permissions. So there are two different types of permissions. This is what we call mobile data consent. So when a customer starts, and the first AppLink app, they start with their with their phone connected, they're going to see this kind of pop-up. So this pop-up informs the user that we're going to use his data connection while the app is connected. What this means is we as Ford, we package up a little informational package on the head unit that is encrypted and send it out through the phone to our backend and get a response from the backend back into the head unit. This includes all of the policy table stuff we were talking about earlier. So your permissions, the specific permissions of your app, if your app is actually allowed to run on the head unit or if it may be shut down and stuff like that. So to get the consent of the customer, we show him this screen and we're going to inform him that we send a couple of data items back to our backend. Don't worry, we don't like monitor what text you're sending to the screen or whatever your app is doing. We're going to keep your data private to your app. But we do have some anonymous usage statistics of different apps. How long did the app run on the head unit? How long has it been started and stuff like that. Note on this, the emulator does not have this permission prompt, so we'll not see it on the emulator, just that you're not confused on the emulator. And then this is what I was referring earlier to as the prompt that the user gets if an app actually has access to specific items. So you can read here the streaming radio player app, which is a test app we wrote. It's not an app that's in the App Store or something, but this test app has permissions for driving characteristics, vehicle information, GPS and speed, and push notifications. So these are different functional groups, and behind these functional groups are different actual vehicle data items. But to make it easier for the customer, we don't actually tell him the specific items. We give him general information about the vehicle data that we will give to the app. And so if the customer says yes, sorry, I go back to the prompt before. If the customer says no to this prompt, an AppLink app will not start. So they will have to agree to this app. But for the next prompt, for this prompt, if a customer says no to this prompt, your app will still run. It will just not have access to the vehicle data items. So we will inform your app that you will not be able to access the vehicle data items. And also on the emulator, again, because we're assuming you're testing, there will be no pop-up on the emulator. So you can go ahead and work with that. And then this is a way for the customer to disable and enable specific vehicle data items later on. So after they agreed or disagreed with the initial prompt, they can always go back in the settings menu and go back to the mobile apps part, see your app, press on the app, and then select and deselect functional groups. So afterwards, if they think, oh, you know what, I want to use this app and I want to give it access to GPS and speed, they can still go back through the settings menu and enable that app with this information. And your app will get a callback that lets you know that now the permissions changed and now you can actually access GPS. And we got that down, so if the user says no, you will not get anything. Quick word on vehicle data simulation. So these TDKs that we have here on stage that you can work with have very limited vehicle data simulation. The TDKs actually give you two different vehicle data items, speed and the prindle position. And based on the button that is in the red box there, if it's pressed or not pressed, it will change to drive or being parked. So these are the only vehicle data items we currently give you with the TDK. But obviously, we have the emulator, and the emulator gives you all these different items that you can try and play with, and also the simulated route and all these kind of things. So there's a lot of stuff you can do with the emulator. And that is also the end of the presentation, which is also the closing part of the AppLink part of this developer conference. So if you guys have any questions on AppLink, we can now address them. Otherwise, we're going to move over to Smart Device Link and the future of Smart Device Link. Yes, please.
I think you kind of answered the question, but you said you don't have access to the, I guess, the GForce data. Do you have access to the track app information?
So you only have access to the items that are on the list. That is always the answer. So if the item you're interested in is on the list, you can use that for your app. If it's not on the list, then we will not be able to add it during this hackathon. But if you're interested in a specific item like G-force, acceleration, deceleration, and different axes, then let me know and we see what we can do for future SDL versions. Right, yeah.
Is there a way to have your app work with both the TDK and the emulator at the same time? So for hardware things like audio pass-through, you go through the TDK. But for things like the prindle, more detail, fine-grained control, you go through the
So the question is there a way to connect your app to the emulator and the TDK at the same time? Honestly, I've never tried that. I doubt that it is possible. If you have the situation that you want to use something that is only available on the head unit, like audio pass-through, but want to use vehicle data at the same time, let's talk later, and we might find a solution. So there is a way to get more simulation into the TDK. It's a quite complicated way, so we don't try to promote that during the hackathon, because it takes a lot of your development time to set it up. But if it's absolutely necessary for your app ID, let's talk about this.
The driving data that you mentioned, the sample route, will that be available through the TDK?
The question is the sample route available through the TDK? At this point in time, the sample route will not be available to TDK. Again, let's talk about this. It will definitely be available through the emulator, and you can use it through the emulator.
What about any PIDs or mill status?
Very OEM lingo question. So he's asking about PIDs or mills, which is, I even forgot what it stands for. Do you remember? What MIL stands for? Thank you, malfunction indicator like, that's right. And so our access to that, answer is no. You get access to all the stuff that is in the list, not to any other vehicle data items. So unfortunately, there's no access for you in that regard at this point in time.
Can I follow up with one more question?
Sure.
Just from a technical aspect, people migrating that want some of these capabilities and features that they previously might have gotten them through a third-party or you can plug in. How do you see the progression of vehicle data either migrating or expanding in order to be able to enable developers to build the sync as opposed to third-party plug-in devices or something?
The question in short was, how do we see the development of AppLink vehicle data items? How will this develop in the future? Generally, you have to see that we developed AppLink together with app developers, and we got their input on what vehicle data items they want, and that was like our basic set we started with, but we're by no means limited to that set. Of course, as an OEM, we're always responsible for safety and integrity of our system, so you will not get full access to the CAN bus or stuff like that. But if you're interested in a specific data item, and we had the G-Force example, if you want to have that, we can definitely talk about including that in future vehicle data sets. So we're more than interested to know what the developer community wants, and we want to integrate that, because in the end, AppLink is for the developer community to create great apps that integrate with the car. So if there's a vehicle data item missing that we should add, let me know, and we're going to definitely note it down and try to put it on stage next year here. All right. Seems to be all the questions. Obviously, we're around. Scott will take over and introduce the SDL part. And I'm going to grab my coffee. Leave.
First off, can we get a huge hand for Timur? He's been busting his butt up here. So, little thing here. Timur actually just got a little promotion in the Ford developer world, and is in charge of his own team handling all of the relationships with the developers. So I put him to work up here and made sure that he was, we're paying him well for it. Thank you very much, Timur. So we've been utilizing the term AppLink and SDL kind of interchangeably during the day, and if you're not entirely sure why, we're going to move into that portion of SDL now and kind of explain how everything that we've been talking about with AppLink and the Ford Developer Program is now expanding and has been expanding into the SDL, into the Smart Device Link world, where our friends from Toyota are going to be implementing. Providers such as QNX and UI Evolution are putting it in their stack, and then we've got many more OEMs that are in the investigation level, as Dave talked about earlier. So right now I'm actually going to invite up Joey Grover, who is the CTO of Livio, who is the SDL project maintainers, and he's going to kick off SDL for us for this afternoon. Joey?
How's it going? Thanks everybody for coming out to the Timur show. The developer conference here. He's been doing a great job. Actually learned some too, so that's always a good thing. Pretty interested in what you guys are going to come up with tonight. Being so close to the project, it's sometimes it's kind of hard to think of the new creative ways that this API can be used. Let's see if we can get this to show. Oh, that looks wonderful. Yeah, always a good idea to check your resolution before you get up here. But anyway, so yeah, I'm Joey Grover from Livio. I'm the CTO. I've been with Livio probably, I think, going on my 6th year now, and started as an Android software engineer. And I'm still an Android software engineer. Actually, I'm the project maintainer for the Android side for Smart Device Link. And so far today, you've gotten a pretty technical level of AppLink and how to connect your app and everything like that. This is going to be a little bit kind of redundant, and then a high overview of Smart Device Link, how it relates to AppLink, and how it relates to a lot of other different OEM brands and things like that. And then we'll kind of move over into the future of Smart Device Link, some things that we have in the pipeline, some things that are like on the verge of being ready, but maybe not quite, and maybe some things that are ready that we just kind of soft released. So at this point, I'm pretty sure we should all know, what Smart Device Link is. At a very high level, it's, does the same thing as AppLink, right? It's the connectivity piece that allows smartphone apps to connect to infotainment systems. Software needs to be on both sides of the module and the actual smartphone to enable the talking. Pretty obvious stuff. What I think is more important is actually how Smart Device Link and AppLink relate, because I think other presenters have kind of mentioned it in passing, but I really want to make sure there's a firm grasp and understanding of how this relationship works. So AppLink was originally created by Ford as a proprietary solution for in-car connectivity. They obviously saw the problem that people wanted to bring apps into cars. It was a big deal, so they created their own API. And then later they announced that they're actually going to open source it, because beyond just this initial problem, there was a second problem. Getting all of those apps connected required more than just a proprietary API. It required an ecosystem to sort of work as a whole in the industry, not just these one-off integrations that were just kind of unmaintainable. So they released that in 2013, and then they doubled down later that year by actually purchasing Livio. And then we've actually become the project maintainers, or the main project maintainers, I should say. There are plenty of AppLink members that contribute to the project as well. So AppLink is now the branded version of SDL. So every time you hear AppLink, or if you're AppLink connecting your app, you're also Smart Device Link connecting that. So any head unit or device that's going to be SDL enabled, your app at a technical level will work. Obviously, there's business issues that you'll have to work out with each OEM and things like that, but at a technical level, the integration should be done. So if we look at that, we have Ford and these other nameless OEMs, or just poorly named ones, that actually contribute into the Smart Device Link open source project. So any features that they want to get in, bug fixes or anything like that, they contribute to SDL. Then they take those projects back into their own brand and do integrations into their hardware. Eventually, they kind of brand them out as different things. So for Ford, that's AppLink, and then some more poorly named connection suites, if you will, could be named the same thing, but the underlying technology is the same. It's Smart Device Link. And what that means for app developers is they integrate SDL into their app one time, obviously. So if we have these apps that are already SDL enabled, they'll work with all of those specific OEM brands. And you can quickly see how the necessity for a standard here really solves a huge problem. If you imagine that each one of these apps had to do a separate integration for every, just even these three, I guess, OEM suites or brands, that's a lot of technical debt to take on. So doing this as an open source standard is very important, not only from the OEM side, but from the app side as well. Now, that's awesome from like a technical standpoint, right? But there's also sort of another aspect of why we need something like this rather than just using the phone. And I found this stat kind of interesting, that 18% of a driver's time is spent not looking at the road, which, 18% doesn't seem huge, but they're behind a large vehicle, and that can do some serious damage. So we want to try to reduce that if we can, and certainly not add to it. But if we extrapolate out, let's say, since we're based in Royal Oak, if we came out of Royal Oak and we decided to road trip it out here to Vegas instead of flying, that would be roughly 29 hours or a little over 2,000 miles, which is it's a big road trip, especially in a Mustang. Over 5 hours of that, or 363 miles, we'd be off the road at 18%. 5 hours, our eyes would be off the road during that trip. So that's essentially as if we were driving across the state of Nevada blindfolded. And I don't know if anyone's, well, I'm sure some people have seen Talladega Nights, but we know that doesn't work out for Ricky Bobby crashing into houses. And I know I certainly wouldn't bet on myself to be able to make it. But moving on, that's why we also do this templated approach, right? Instead of just a video out solution for all of these things, we give the OEMs the ability to control the user experience in a safe way. And that's extremely important. We do things like providing driver distraction notifications back to the application so they can pop up their lock screens, and force the user to actually use the integration on the head unit itself. So if we look at the actual template, it's pretty easy to see some of the different things we've been talking about today as far as like show, soft buttons, and images. You have your text updates on the side using the shows. You have image updates, whether that's, album art, app icons, etc. You have the actual soft buttons that you can control. So this kind of gives the apps the ability to have a little bit of their brand into the template that the OEMs put out. So it's not just a straight OEM brand that they're seeing. So obviously Pandora has a thumbs up, thumbs down, which is very important to them, right on the front screen for the users to see. And then obviously media apps, this is the transport controls. And this is just the one example of where these things all go for the media template, but obviously there's quite a few more which we've seen today. So the next interesting point is that at Livio we kind of saw a lot of implementations, their templates are all static, which is good in some sense. But it leads to some weird corner cases. Most notably here, we're thinking about a media application, like an internet radio player, and obviously one of the things they populate is the album art, right? But what if they can't find it, or what if they can't download it, and things like that. A lot of cases the template would just put up a blank square, or maybe the app icon to handle that case. And that's okay, it looks fine, but I think we can take a step above that, still using this templated approach, but making templates smarter. So we take a look at this, which is actually a future project that we're in the middle of developing, the generic HMI, we're just kind of calling it, but it's Livio's take on what an HMI can look like using this templated approach. So obviously this is very media-based. You have your metadata, the album art, time, transport controls, all that's pretty standard. But then looking at this corner case, we decided, well, that could actually change. Like now there's no album art, so let's make our text bigger. Let's make that more readable. Let's sort of rearrange some of the other text to make it more forefront rather than crowded. So looking back, it's both of them independently look good. But at the same time, the app doesn't need to know that these are two different templates. They can just be smart about the information they're receiving and then change accordingly. Just kind of looking at this a little further, obviously these are the kind of show fields that you have, the main fields, the track time, album art, things like that, and the soft buttons down at the bottom. So I kind of mentioned this to start. This is our take on what could be done. And currently we have the media template done, and we're trying to demonstrate this as an example HMI for OEMs. and kind of show them, you know, just because this is a template doesn't mean that it has to all look the same. A lot of this stuff can be implemented to make the experience a lot better for the user. The media template is the one that's actually done, and it's in GitHub right now. It works with the core project. It's all done in HTML5, and I think Scott is actually going to talk a little bit more about it as well in one of the coming talks. So this is probably about as technical as I get with a subject, and it's multiplexing Bluetooth for Android, which people on my team know is sort of my project, and I've been working too long on it, but it's now in the develop branch, so that's a good sign. And the reason it's important is different Android devices actually have different RFCOMM channel limits, and of course there's no standard between all of those devices, so it could be as little as 0 to 1 or 100 or anywhere in between, honestly. So that also leads to a problem when infotainment systems may only have a single channel or only want to dedicate a single channel to this a smart device link connectivity. So we decided that we needed a way to actually communicate through just one RFCOMM channel rather than many. Like I mentioned, it's in the develop branch right now. So if we look at it from an infograph sort of perspective, how it is now, every app actually maintains their own RFCOMM channel. So if we have 3 SCL-enabled apps on our phone, that means that 3 RFCOMM channels are being used. And those will all talk to the SCL-enabled infotainment unit, and that infotainment unit will also have to use 3 RFCOMM channels. But the thing is, not all apps that use RFCOMM channels will be SCL-enabled, so we can't just assume, oh, we can only have so many SCL-enabled apps on the phone. There could be many other apps that listen to different RFCOMM channels using different UUIDs for different purposes, and it's sort of a first-come, first-serve with Android devices. So let's say this phone only had those 4 RFCOMM channels. That means the 5th one, who's late to the party, doesn't get one, and that means he won't show up on the infotainment unit. So that's a bad experience. So what we've decided is we'll have these apps actually connect to a router service that's not unlike a router. That connects to one RFCOMM channel that then connects to the infotainment system with one RFCOMM channel. So there's only a single channel here being used for all of these apps. So even though there's a different app that has a different purpose for its RFCOMM channel, now we're only using 2. And if we want that 5th app to appear, it actually doesn't need to listen to its own, so it doesn't care how many channels are left. It just connects to the router service and connects through the already open RFCOMM channel for all of the other apps. Enhanced frameworks for the mobile proxies. So I don't have a lot of information on this right now because there's not a whole lot ready for it. There are some things that are in some of the development branches, and there's some pull requests. But essentially, it's just trying to make the whole experience better for the developer, and a lot of focus around bookkeeping. So I guess my example would be like a show. When you want to do a show, you have to send a put file. If you want to use an image, you have to wait for that put file to get a success back, and then you can send your show. So the enhanced framework should be able to take that into account, and you can just supply it with the image that you want to send, and it can do all of the underlying RPCs for you rather than you having to use each one and wait for the responses. So I kind of blaze through some of these bullet points, but yeah, some of it's already in the open. I think the iOS library has more already merged in. However, the Android library has a ton of active pull requests that are open right now. They're all tagged with work in progress, but I think by the end of the year is our goal to get these in. The next feature is Smart Device Link Remote Control. This is a piece we've been working on for a little while now that I think is pretty cool. It actually allows apps to control, I call them like non-primary or non-critical pieces of the car. So for example, those are like climate control, radio, maybe seats or things like that. Something that if an app is going to control or set a wrong value, it's not going to mess up the car. It's not going to cause a crash. Nothing like that. It's very secondary to what the car's purpose is. In the Livio booth, we actually demonstrated this with a partner, Next Radio, which, if you know what the Next Radio app isn't or is not, it actually uses the FM tuner on your phone to actually tune into FM stations. So what we did is we used this remote control branch to actually control the car's FM tuner. So to the user, it really doesn't seem like anything great, but it's really cool to not have to stream data or anything like that. You're just using the FM tuner, which is going to be a better quality than the one on your phone, and it's not going to eat up the data as if you were streaming it. But you still get all of the sort of enhanced experience with album art and metadata from the Next Radio app pushing over through normal smart device link. This is another feature we're hoping to have in by the end of the year. So let's take a little look at an infograph. So if we have a radio app like the Next Radio app, it connects to the infotainment system using the Smart Device Link remote control branch. When it makes a request to change like a radio station, it's actually the infotainment system that routes it to the right device and says, okay, yeah, I can change that, so I'm going to, and feeds back response to the radio app saying, yep, it's changed. But where it gets interesting is when we add other devices into the car. So for a radio app for the driver, that might not seem too exciting because he's just going to use the radio probably on the infotainment system. But now we could have some passengers that have actually like climate control apps. So they connect to the infotainment system using this Smart Device Link remote control. They request permission. That's kind of set up OEM or head unit independent, but it's in the protocol to make sure that these apps have permission to control these modules, usually by driver's preferences. And then same sort of thing, the climate control module gets the request from the infotainment system. So here, the passengers are actually controlling their own climate zone, which is really cool. And that's part of the demo we did actually at CES, where we determined where a person entered the vehicle, and when they entered the vehicle and sat down and connected, their climate control zone changed automatically to their preferences. The next piece I won't spend too much time on because I think Scott's going to give you a lot better and tutorial and in-depth overview of the developer portal. But essentially, we recognize the need to have a centralized location for all of these documentation, rather than OEM-specific sites or dev portals to make it easier to maintain and to be up to date. We actually made all of this documentation open source, which I think is one of the coolest pieces about this. So if anyone notices an error, they can submit an issue or actually submit a fix, which is pretty awesome. GitHub, I'm hoping everyone here knows what that is and how to use it, but that's where the Smart Device Link project is hosted. We follow the Git flow process, which again, I think Scott's gonna go through in detail in case you didn't know. And the only real requirement other than that is that you'll have to sign a CLA in order to contribute to the project, but anyone can contribute to the project, and anyone can raise issues without signing the CLA and anything like that. So the next piece is pretty new, actually. We wanted to sort of formalize a process of how we introduce new features and how we architect certain things. So if anyone has worked with the Swift open source project from Apple, this will seem very familiar because we tried to emulate it as much as possible because it seems to be working really well. Basically, we have this repo in the open source that allows different people to submit feature requests and comment on those that are already submitted. And it's important that everybody gets to see this whole process instead of some of it happening behind closed doors, not even on purpose, but it was very hard to communicate out to the open source community how we're making these decisions. So the other piece is that anyone can actually create proposals. So if you have an idea, if you have a feature request or something like that, this is the place to do it. We have templates that will show you how to create the proposal, and a lot of guides telling you how this process actually works. So essentially, you start with the proposal that you make. You submit it for review, and a steering committee or engineering work group, the nomenclature is just a little weird there, but it's an engineering work group for all intents and purposes. Basically decides, okay, this proposal has been submitted for review, and based on how many they have at the time, they'll then say, okay, let's let the open source community sort of talk about these, discuss them, and go from there. So they get accepted for review. And the open source community then receives an email, a notification saying, you know, these X amount of proposals have actually been accepted for review, which is a weird sort of naming scheme, but anyway. So they'll have 7 days to review the proposal and give their feedback, whether it should be accepted or not, if they want to see anything changed, et cetera. And then it kind of funnels back to that steering committee. The steering committee then has to make a final decision. They take back all of the feedback that's occurred in the open. They discuss it amongst themselves, and you know, for the most part, everything is usually heavily weighted as a positive or a negative, and these decisions are very easy. Some things might get deferred or tabled for a later date if there was not enough of a consensus. But either way, anytime the group makes a decision on that, there will be proper feedback and kind of information about why the steering committee chose, you know, the outcome they did. The three most common here are obviously accepted feature just outright, so the proposal is then accepted, you know, and then it's a whole other process to take that feature and actually do the work to incorporate it, but at a high level, the feature has been accepted. Or there's accepted with changes, pretty self-explanatory. There's usually something minute or otherwise that needs to change before we can sign off saying the feature is good. It's mostly we accept it sort of at a high level that this is okay and this is a good idea to incorporate, but some things might need to change a little bit in order to say that it's getting pushed into the actual project. And then there's obviously the rejected pile where no one wants to be. And again, that'll have good feedback of why we believe it's not accepted. You know, usually it's sort of out of the scope of what Smart Device Link is, or it's just a bad proposal in general. And then there's the Slack channel. If anyone here is not on the Smart Device Link Slack channel, I advise them to join immediately. There's actually a hackathon channel that includes both this group and the group that's in Berlin right now. And I think all of the supporters here are on that channel, so if you see one of us busy or others can help you, just type your question into there and it usually gets answered. Beyond that, there's also different channels for, you know, different pieces of the project itself, like Android, iOS, the core side. It's just a great way to get instant feedback on things and to get your questions answered, because all of the basically technical experts in the world are usually on there. So it's a great tool to use. So with that, as I cruise through this presentation, are there any questions? That's a good question. So essentially, summarizing, basically, is it up to the OEM to decide if you have access to that module?
I suppose so, yes. So even though you all have the feature from an SDL, some of them are
Yes. So using remote control as sort of the example here, that's very true. While Smart Device Link as a whole tries to provide a lot of these features, it's always going to be OEM specific as to what they will sort of give you or give the developer access to, and that might change based on model as well. So it does get a little hectic, and there's some bookkeeping obviously to keep track there. But with remote control specifically, you send out a like get interior vehicle data capabilities, which is a mouthful for an RPC. But essentially, it'll send back all the modules that you have access to. So you'll know right away before you even try to do anything if there's the module you're looking for. Yep.
One other question in that throughout this whole process, sync and this and that, nothing has addressed security. Is that just a non-starter we get when the car explodes, or ignore it or go away?
No, definitely not. I guess more specifically, as far as security, is there an example, or there's?
Okay. You were talking about getting in the car and you have an SUV.
Mm-hmm.
So you have 3 rows of seats. And the back 2 rows want to do their own time. Well, you're sitting down there and you talk about having some kind of sensor thing. Thermometers. There must be somewhere there. And someone sits down and decides, well, I'm going to burn row 2. Everybody else is going to for you to go to the slot. Or the windows are going on. Or the trunk is or your infotainment system just trips. These are basic things because we have access, we have input, but we have no filter or plan to tell who's good and bad.
No, I mean that's a good question. As far as Smart Device Link kind of looks at that, and how Livio looks at that, that's going to always be OEM specific on how they allow that to happen. However, there are different features that allow control over that. Like we have policies, which I think actually Scott is going to talk about a little bit, maybe not. But essentially, that will control which apps have access to which RPCs and things like that. So for one of the base case like permission functionality things we did for RC was that basically the driver always has control over whether or not an app can control those modules. So the request would come from like the 3rd row saying I want to control my climate zone, and it would pop up as an alert or something like that. You want to give permission to this phone to do this or something like that, and they can accept, deny. And that's a very manual process to do it by. But the idea is that the feature for that security is enabled, but it's not necessarily flushed out from the Smart Device Link. That's sort of an OEM decision on how to handle that specifically. Right. Yeah. All right. If there are no other questions, I believe I'm going to invite Scott back up here for some fun. Thanks.
For Joey. According to Mr. AT&T, it's 3:38, so we will take a 10-minute break. Grab yourself something to drink out there, stretch the legs, call your mother.